Hello and good afternoon friends, welcome once again to the CEC-UGC live lecture. Dear friends, as you know that from time to time we talk on different topics, and with the help of these topics we believe that we reaches you, we help you in studying the various content. So dear friends, in today's lecture we are going to talk on cloud formation and precipitation. We are going to discuss how clouds are formed, and later on we are going to discuss on precipitation. And for this we have today again with us in our studios Dr. Arun Kumar Srivastav. Dr. Arun Kumar is Assistant Professor in School of Environmental Sciences, Jawaharlal Nehru University. So dear friends, let's take advantages from his experiences because Dr. Srivastav keeps on taking the lectures within the classes, and with those lectures he tries to understand what basically student wants and what basically student wants to learn. So dear friends, taking this lecture forward, once again I would like to welcome our guest Dr. Arun Srivastav. Dr. Srivastav, welcome to the EduSet lecture.
Thank you very much.
Though cloud formation and precipitation are the terms which most of the students have heard or must have read about, but I firmly believe that from today's lecture the students are going to get more in-depth knowledge on this very topic, that is cloud formation and precipitation. So over to you, sir.
Okay, thank you. Good afternoon everyone. Today the topic of discussion is cloud. In fact, we will be discussing cloud, what exactly cloud is, how it is formed, what are the processes that are involved in the formation of clouds, what clouds after forming, because it is not that cloud is once formed, it will start raining, because formation of rain is again a very difficult and very complicated process. So, the formation of rain after the formation of cloud is also very important. So, if we will have time, we will discuss the formation of precipitation also, either today or tomorrow. And today we will try to cover the type of clouds, because as far as our knowledge, our general knowledge is concerned, clouds are, for us, clouds are something which are there in the sky, floating from one place to the other, having some fixed colors, either white or yellowish, reddish sometimes, brown, dark brown, gray, etc., etc., and it might give rain or sometimes not. Sometimes lightning, etc., can also occur in the cloud. But cloud is something beyond what our general perceptions are. Clouds, in fact, cloud is a big science. Cloud is a very big science. So, today we will discuss exactly what clouds are and what are the processes that are involved in the formation of clouds and how many types of cloud can be there in the atmosphere. So, starting from clouds definition, what cloud is, clouds are exactly, basically clouds are made up of teeny drops of water or ice crystals that settle on dust particles in the atmosphere. The droplets are so small, as far as diameter is concerned, it could be about 1/100th of millimeter, I mean 1/100 millimeter, and this there can be over 100 millions of water droplets in a cubic meter of air. Apart from this, these clouds also can be said as these are suspended particles and are also known as aerosols, and this, in fact, the physics or science where we study the cloud physics is a big branch of science. It is known as nephology. In fact, we will this comes later, and again in continuous to the definition of clouds. Clouds will either be composed of ice or water droplets depending upon the height of the cloud and the temperature of the atmosphere. Because the droplets are so small, they can remain in the liquid in temperatures as low as minus 30 degrees centigrade. Here you will be surprised that even at minus 30 degrees centigrade, why the phase does not change. I mean, it shouldn't be water, but at this low temperature it should be solid particles. So, what happens actually, because the droplets of clouds are very, very small, these are really tiny, I mean they are in the size range of some micron. So, at that smaller size, the particles continue to persist in the form of liquid, I mean in the liquid phase, it does not change its phase. But if the temperature further drops to minus 30 degrees centigrade, so the phase changes and it can be converted into the ice crystal. Again I will say here the science, I mean the science which covers the cloud is known as nephrology. Now again, in the definition, continuing with the definition, they are formed mainly as the result of vertical motion of the air. What happens actually? The air starts moving from ground, if the air starts moving from the ground towards some height in the vertical direction, and in fact there a convection occurs and or in forced ascent over the ground, or in large scale vertical motion associated with the depression and fronts, the formation of cloud happens. With the exceptions of certain rare types like nacreous and noctilucent and the occasional occurrence of cirrus in the lower atmosphere, clouds are confined to troposphere. I think in the earlier classes we have discussed about the stratification of the atmosphere, that the atmosphere is divided into various layers starting from troposphere, which is at the lower part, troposphere, stratosphere, mesosphere, exosphere, but the clouds generally remain in the lower portion of the strata or lower level of the atmosphere, that is troposphere, but sometimes, I mean rarely, they can also occur in the stratosphere. The upper limit of the troposphere is up to 15 to some places, at some places it could be up to 20 kilometers. So clouds can be expected maximum up to 15 to 20 kilometers, but there are some rare events in which the clouds occur even beyond that limit, I mean in the stratosphere. Those are specific clouds, they are nacreous and noctilucent, and sometimes the cirrus cloud. We will discuss about the types of the clouds later in the later parts of this lecture. So the clouds are mainly confined in the troposphere part of the atmosphere. Now the formation of clouds mainly depends on the atmospheric instability and vertical motion, but it also involves microscopic processes too. The most important and fundamental parameter in the cloud formation is CCN, which is also known as cloud condensation nuclei. We will be discussing cloud condensation nuclei in detail in the later part of this lecture, but coming back to the formation of clouds, how the clouds are formed. Clouds form when the invisible water vapor in the air condenses into visible water droplets or ice crystal. There is water around us all the time in the form of tiny gas particles, also known as water vapor. What happens actually? Water, generally what we see, that is in the phase liquid. So water is in the liquid phase, but because of the vapor pressure and the ambient temperature, or due to the raised temperature, this water vapor gets converted into the gaseous phase. This water gets converted into the gaseous phase, that is water vapor. The conversion of this liquid phase to the gaseous phase mainly depends upon the vapor pressure of the atmosphere as well as the temperature, ambient temperature. So what happens once this liquid phase of the water is converted into the vapor phase? It is generally not visible. But what happens when the temperature, if the water keeps on ascending, it keeps on going up and up. So what happens? The temperature keeps on dropping, and this drop in temperature force that water vapor to get converted into the liquid. Here the invisible water vapor gets converted into the visible or white colored vapor, and that is actually the cloud. Here the phase is transformed as well as the color is transformed. So how this is the beginning of the formation of the cloud. We will discuss it again in detail. There are also tiny particles floating around in air, such as salts and dust. These are called aerosols. These aerosols are these tiny particles which are also known as CCN, what I have told in the beginning. This CCN is fundamental part, or we can say it is the mandatory part in the formation of the cloud. If there would have been no CCN, the formation of cloud is impossible. The cloud cannot be formed. So CCN, which could be of any composition, it has got many chemical composition, many varieties, many shapes and sizes, and in fact they are very tiny, are the fundamental or we can say it is the primary requisite in the formation of the cloud. So, once the CCN or the cloud condensation nuclei is present, the formation of clouds begin. What happens? Suppose there is a CCN or the cloud condensation nuclei is present. What will happen? The water vapor which is already present in the atmosphere will start condensing around that particular tiny particle, that is CCN. So, once it starts condensing or once it has been condensed over the surface of the CCN, then other water particles which is in the form of water vapor will start condensing over that water particle. So, this is how the condensation process begins and the size of that particular water droplet start increasing and further increasing. This increase finally results into the formation of cloud. So, in fact, they are stepwise. This is a stepwise process. So, we will discuss it. The water vapor and the aerosols are constantly bumping into each other. I mean, there is a mutual interaction continuously. So, what happens when the air is cooled? I mean, air has got sufficient low temperature, some of the water vapor start sticking on that tiny cloud condensation nuclei, and once that water vapor has got stuck onto that tiny particle, the condensation begins. Eventually, bigger water droplets, I mean the water droplets which are comparatively bigger than the previous one will start condensing upon that particular particle, and this is how the formation of cloud is started. Now, clouds form when the air is saturated. One more thing is that air should be saturated before the cloud formation begins. If the air is not saturated, I mean the formation of cloud is not possible. Now, the question is what exactly the saturated air is. What is air is composed of? Air, I think in one of the lectures I have already discussed about the composition of air. Air is composed of many of its components. The maximum is nitrogen, then oxygen, etc., etc. Among those components, one integral part or another important component which is actually variable is water vapor. Water vapor, the component of atmosphere is variable. So, what happens, since the water vapor is there and since I told that water vapor is not constant, its composition or its concentration in the atmosphere from place to place, from time to time keeps on varying. The reason is there are so many water bodies, and these water bodies keeps emitting or keeps giving the water vapor into the atmosphere. This is why the water vapor concentration is not constant in the atmosphere. So, suppose at any particular place or at any given place, water vapor's concentration is there, but the input of water vapor is also there. I mean, water vapor is also getting included into the atmosphere continuously. So, what will happen? It is not that this inclusion of water vapor be always there forever, I mean for infinite time. This has got a limit. I mean, and the limit is when there is enough water vapor in the atmosphere that the atmosphere cannot hold further water vapor, and that level is known as saturation level for the water vapor. So, once the water vapor is enough, and if there are some cloud condensation nuclei or the smallest particles present in the atmosphere, then the condensation will begin. I mean, there the water vapor's phase changes, and it changes from gases to liquid phase, and this is how it will create some space for the inclusion of water vapor which is coming from some sources present on the ground or on the earth's surface. This is how there will be creation of a space for the inclusion of water vapor. Simultaneously, there will be the formation of clouds. This is how the clouds are formed. Apart from this, the air is cooled to its dew point, the point where the condensation occurs. I mean, the dew point is a temperature where the condensation will begin. Or we can say it is not that the condensation can occur at any point. Condensation will occur at a certain temperature. below which the condensation will occur, above which the condensation will never occur. That temperature is known as dew point temperature. So, here there are two points which are very important for the condensations to occur is the amount of vapor, water vapor in the atmosphere has increased sufficiently so that it has achieved its saturation level. This is number one. The number two is the temperature should be, the atmosphere should attain a dew point temperature. Once the atmosphere has attained the dew point temperature, then the condensation will start occurring. Now, the warmer the air is, the more water vapor it can hold. If the air is warmer enough, the chances are there it can hold or it can accommodate more amount of water vapor. Clouds are usually produced through condensation as the air rises. It will cool and reducing the temperature of the air decreases its ability to hold water vapor so that condensation occurs. The height at which dew point is reached and clouds form is called the condensation level. The height at which dew point is reached, where the dew point, the temperature, because as we go up, the temperature decreases continuously. So, there is a, this decrease in temperature also varies from place to place. It is something different at polar level, it is different at equator level, it is different at some other places. But it is certain that as we go up, the temperature decreases. So, what will happen? Because I have already defined what is dew point temperature. So, this decrease in temperature will during this decrease in temperature, we will reach to a point where the dew point temperature has occurred. This exactly that level where the dew point temperature is there is known as level of condensation. Above which if there are water vapor, the chances are there in the presence of cloud condensation nuclei, the condensation will take place. What causes the clouds to form in continuation to that only? There are 5 factors, 5 important factors which can lead to air rising and cooling and cloud forming. Number 1 is surface heating. What is this surface heating? This happens when the ground is heated by the sun, which heats the air in contact with it, causing it to rise. The rising columns are often called thermals. What happens during day period when sun is there, the surface of the earth is heated. So, the air which is in touch or which is in the contact to the surface of the earth will be heated in comparison to the air which is above the surface. So, what will happen, because the lowest one is hotter, above that is hot and above that is comparatively less hot. So, the air, to adjust this temperature, the air which is at the ground level or in the contact with the ground will keep on rising or will keep on ascending. It keeps on going up and down, and in fact, this column of air, which it is not that it will happen everywhere, there should be a specific circumstances for that, and once this rising or ascending of the air starts from surface to the upper level, that is known as those columns where this phenomenon is happening is known as thermal. So, this is how the air column is going up and up, and once it reaches to a certain level, what we have already discussed, which is known as condensation level, and if there are the presence of cloud condensation nuclei, or the condensation will begin. So, this is one of the reasons for the formation of the cloud, that is known as surface heating. Apart from that, the next one is topography or orographic formation. This is different than the surface heating. What is exactly this topography or orographic forcing? The topography or shape and feature of the area can cause to be formed. When air is forced to rise over a barrier or mountain or hill, it cools as it rises. Layered clouds are often produced there in this way. What happens in the mountainous region? There are surface features or there are surface topography which actually forces the air to rise. It is not because of the heating of the surface, but it actually is because of the surface features. So, what will happen because of because of those features, if air starts rising up above and above, up and up, then this temperature will decrease, and once the level of condensation is attained, that there the condensation will begin. Apart from that, the third one is frontal. This is also one of the processes by which the formation of cloud can take place. Clouds are formed when a mass of warm air rises up over a mass of cold, dense air over large areas along fronts. A front is the boundary between warm, moist air and cooler, drier air. So, what happens if there are two boundaries? I mean, if there is a boundary which actually dissect or differentiate the cold air to the hot air. This is where if there is a cold air and if there is a hot air along the boundary, and if there are presence of cloud condensation nuclei. So, what will happen? The hot air which is there, as soon as it gets into contact with the cold air which is comparatively denser, the chances of the condensation will begin there. So, this is the third process by which the possibility of condensation is. The fourth one is convergence. What happens? A stream of air flowing from different directions are forced to rise where they flow together or converges. This can cause cumulus cloud and showery conditions. We will discuss it later on. What will happen if there are streams of air from different directions are coming at one point, and where the meeting point is, what will happen after collision, after getting in touch with each other, the air which are coming from different directions will start flowing up and up. This is how the process of getting the air to the upward direction is achieved, and as soon as it reaches the level of condensation will begin, provided the CCN is there. The fifth one is turbulence. A sudden change in wind speed with height creating turbulence eddies in the air. If there is a turbulence, or if there is a sudden change, very sudden change in the wind speed and height, what will happen? The air will cool. Suddenly the air will cool, and if this cooling is below or at the level of dew point temperature, the possibility of condensation is there. So, but because we have discussed the different type of processes by which the clouds can be formed, and in different conditions, this is how these are the regions, these are the specific causes why we get or we see different or various type of clouds having different shapes, different sizes, different texture. Now, we will discuss what exactly cloud condensation nuclei is. In fact, I have already told this is the fundamental requirement for the formation of clouds. In fact, this cloud condensation nuclei are also known as cloud sheets, and in general term or in customary way it is called as CCNs. We generally say it CCNs. What CCNs are? Actually, CCNs are small particles of solid or liquid, typically 0.2 micron or 1/100th of the size of cloud droplet on which the water vapor condenses. So, what we can say that whatever the cloud's particle size is there, this CCN is even further smaller to those cloud droplets, and this is not one time or two time, it is 100 times smaller, or it is 1/100th of the size of the cloud particles, and its general size is usually 0.2 micron. And in fact, water requires a non-gaseous surface to make the transition from vapor to a liquid. This process is called condensation. Without condensation nuclei, the surface tension of water droplet is too much for the droplets to stay together, because one can ask question why there is a need of cesium or some foreign particles or some other particles, why not water droplets which can act as a seed material for the formation of the cloud. But the problem is, if there is a water droplet, so the possibility of the water vapor to condense around that particular water droplet is impossible, because the surface tension of that water droplet is actually extremely higher than that of any foreign solid particles. And if the surface tension is too much or very high, the chances are very less that the water vapor will be hold together or can be stick to there with that particular water vapor. And this is why the need of foreign particles as a cloud condensation nuclei is there. The nuclei enable condensed droplets to grow large enough to become cloud or in due course of time in the form of rain droplets. Now, here in this particular picture you will see about the cloud condensation nuclei and what is the variation in the size of the cloud condensation nuclei and the size of the water droplet. The picture in the right hand of the screen, you can see that how much is the difference between a water droplet or between a raindrop and the cloud condensation nuclei. It is a huge difference. And here at the bottom corner of the in the bottom corner of the right side's picture, and in the right side is given the size of the condensation nuclei, which is of around 0.002 millimeter, and at the top is the size of the water cloud droplet, and in the left hand of the right side picture is the size of the raindrop. So, we can say here that in fact there the picture is there is a picture of 3 droplets. One is raindrop, another is cloud drop, which is basically the water vapor or the gaseous phase of the cloud of the rain, and one is rain, which is the liquid phase of the water, and there is a picture of the cloud condensation nuclei. So, the difference is huge. There is a huge difference from cloud condensation nuclei to cloud droplet to the raindrop. So, there is a very big difference, and in the left hand side we can see how the formation around the cloud condensation nuclei of the cloud takes place. So, we can see at the top of the at the left hand side of the picture, and top of the left hand side picture is given the picture of hygroscopic nuclei. This hygroscopic nuclei means which can be moist very easily, or which can receive water vapor, I mean which is we can say which is hydrophilic, I mean which can attract the moisture, which can attract the water vapor. So, here what happens, hygroscopic nuclei, which is obviously the cesium is present there, and around which the droplets of water vapor are getting stuck, whilst in the left hand right hand side of the left hand picture is a picture of hydrophobic nuclei. Here, if the cloud condensation nuclei is of hydrophobic nature, I mean which usually repels the water, any form of water is known as hydrophobic. So, what happens, the water vapor after colliding over it gets reflected or gets refracted. It is not stuck over it, but in the hygroscopic or hydrophilic nuclei or hydrophilic particles, the water is getting stuck over it. So, in due course of time, this water vapor is keep on attracting over getting attracted over the CCN, and it keeps on growing further and further. This is how we can understand with the help of this picture the differences between the sizes of CCN, the water vapor or the cloud, and the rain, as well as we can understand how CCN plays a very crucial role in the formation of water vapor, in the formation of cloud droplet, and due course of time the rain. If there is no CCN present in the atmosphere, we can't expect cloud to be present in the atmosphere. Now further, as far as the specialities, or again describing about the properties of cloud condensation nuclei, there are many different types of atmospheric particulates that can act as CCN. I mean, the nature of cloud condensation nuclei can vary tremendously as far as its chemistry as well as its physics are concerned. The particles may be composed of dust or clay, soot or black carbon, from black carbon which is generally originated from grassland or forest fire. Apart from that, very important and very common are sea salts. Sea salts which are generally originated from the ocean region, they are very important CCNs as far as in general the cloud formation across the globe is concerned. Soot which are generally originated from factory or smokestacks, internal combustion engines. They are also very important in the formation of cloud condensation nuclei. Sulfate from volcanic activity. Apart from that, some living organisms or dead, I mean which are not chemical or which are not inorganic but organic matters like phytoplankton, or they are also sometimes act as the cloud condensation nuclei. Apart from that, secondary aerosols can also act as cloud condensation nuclei. These secondary aerosols could be either sulfate aerosols or organic matter, which are usually formed due to the oxidation of volatile organic compounds. The ability of these different types of particles to form cloud droplets varies according to their size and also their exact composition, as the hygroscopic properties of these different constituents are very different. What I mean to say, since I have already told CCN plays a very important role in the formation of cloud, the composition of CCN also does vary. It varies tremendously as far as its chemistry is concerned. If it is soot, definitely it is purely carbon. If it is salt, it is, I mean either it could be calcium chloride or sodium chloride, etc., etc. Apart from the chemistry, the sizes of those CCNs are also important in the formation of cloud. So the cloud what has been formed is basically a representation, sometimes also we can say that it is a kind of representation to the forming CCN, or from which CCN it has actually originated or it has actually been formed. Sulfate and sea salt, for instance readily absorb water, whereas soot, organic carbon and mineral particles do not. What I mean to say, sulfates and sea salt, what I have already told that sea salts, the oceanic salts play a very important role in the global CCN, in global total CCNs. So the sulfate and CCN, because one major reason is its abundance is more, because the globe is surrounded, we have around 70% of ocean around us. So we have abundant amounts of sea salt as far as sulfate aerosols, because sulfate aerosols are anthropogenically hugely emitted, and apart from its abundance, one major reason is that it has got a tremendous hydrophilic property or hygroscopic. It has got a very important hygroscopic characteristics. That is why it plays, or it can readily absorb the water vapor present around this. So this acts as a very important and very fast cloud condensation nuclei. But as far as the other CCNs like organic carbon, mineral particles, shoots, etc. is concerned, their abundance is not that much in the atmosphere in comparison to sea salt, as well as it is not that hygroscopic or that hydrophilic. I will not say that it is hydrophobic, but it is not that hydrophilic, and that is why it does not play that important role, or it is not that fast as far as the formation of cloud is concerned, acting as CCN. They do act, but apart from this, it can act as a good ice nuclei, not cloud nuclei, but ice nuclei, especially in the colder parts of atmosphere. Clouds forms when the invisible water vapor in the air condenses into the visible water droplets or ice crystals. For this to happen, the parcel of air must be saturated, that is unable to hold all the water it contains in the vapor form, that what I have already discussed. So, it starts to condense into liquid or solid form. There are two ways by which the saturation can be reached. So, I think saturation I have already discussed. Excuse me. Now, we will discuss how the saturation can be attained. There are different two mechanisms how the saturation can be achieved. One is by increasing the water content in the air, I mean water vapor. Water content means water vapor which is there in the atmosphere should keep on increasing and increasing through evaporation, so that it should reach to a point where the atmosphere cannot hold any further air, cannot hold any further water vapor. The second one is by cooling the air so that it reaches to its dew point. This is the temperature at which the condensation occurs. I think we have discussed earlier also, but here we will see it diagrammatically where one can understand even in better manner, and is unable to hold any more water. This figure actually shows how there is a maximum amount of water vapor the air at a given temperature can hold. Here in this curve, there is a evaporation curve. Along y-axis is the vapor pressure, along x-axis is the temperature, and there are one line in between or one curve in between which is known as evaporation curve. Here we can see the if that particular water vapor is above that or towards the y-axis of that curve, the chances are there it will condense, because it is below or it is at the dew point or below the dew point temperature. So, the chances are there that the condensation will occur, but if the water vapor is below this curve, the chances are very less that the condensation will occur. Especially in this gray region, we can see here this broad gray region, which is I mean there are dotted line along x-axis as well as there is a dotted line along y-axis. So, this gray region, especially we can say it is a region where the saturation has already occurred, and if further increase in water vapor is there, then the condensation will begin. So, and in fact this temperature, what this graph basically varies from place to place as well as from time to time. This can, I mean the temperature range as well as the vapor pressure range can change from place to place as well as from time to time. Now, in general, the warmer the air, the more water vapor it can hold. Therefore, reducing its temperature decreases its ability to hold water vapor, so that condensation can occur. This is the usual way that clouds are produced and is associated with air rising in the lower part of the atmosphere. Now, here in this particular picture you will see, as the air rises it expands due to lower atmosphere. What happens as we go up? The pressure decreases as well as the temperature decreases. So, there what will happen? The air which is there, because of the lower the pressure, it will start expanding. As since it start expanding, its temperature decreases. In fact, from ground to up to some specific level where the saturation till the point where the saturation has not occurred, the temperature reduction is 1 degree centigrade every 100 meter, and after that once the saturation is achieved, the reduction in temperature is 0.5 degrees centigrade per 100 meter, or we can say the rate of cooling in the downside below the saturation point is 1 degree centigrade per 100 meter, above that is 0.5 degree centigrade per 100 meter. The rate of cooling depends upon the water content, humidity of the air. We can say the moist parcel of air may cool more slowly at a rate of 0.5 degree centigrade per 100 meter below the saturation point. Therefore, the vertical ascent of air will reduce its ability to hold water vapor, so that the condensation occurs. The height at which dew point is reached and cloud is formed is called as condensation level. What we have already discussed it actually, but here it is better diagrammatically represented. Apart from that, the surface heating, what we have discussed, is represented here. We can see at the ground the bottom of the ground of the earth's surface is heated by sun rays, and that heating basically causes the air parcel to lift up and up, I mean the water vapor. It keeps on lifting up, and as soon as it reaches the condensation level, this condensation takes place and the water vapor is converted into cloud. The next one is frontal, what we have discussed. Here the topography, we can see here, because air is going from left hand side to right hand side, but it is finding an obstacle, very big obstacle. The height of the obstacle is up to the condensation level. So, what will happen, since the air can't cross that obstacle, it starts going up, it starts rising up. So, if that height of the obstacle is approximately up to the condensation level, what will happen? Again, the water vapor will get converted into the cloud. The next one is convergence. I think we have already discussed. Convergence is represented here diagrammatically. Here the air is getting converged from many directions, especially here in this particular picture it is given from 2 directions, and they can't cross each other, they can't overpower each other. So, they keep rising together jointly, we can say, and if the rising is up to the condensation level, again the water vapor will get converted into the cloud. Now, apart from that, now so far we had been discussing about the formation, how the clouds are formed, what are the basic needs, what are the basic circumstances of the formation of clouds. Now, we will discuss the cloud heights. Cloud heights are also very, very important as far as the cloud science is concerned. Observations have shown that the clouds level, with the exception of nacreous and noctilucent clouds, the range vary over altitudes from near sea level to up to 18 kilometers. I mean, definitely it has to be confined in the tropospheric region. This 18 kilometer is approximately 60,000 feet, and in tropics this will be up to 14 kilometer. I mean, it is further lower, because the troposphere's upper limit is lower in tropics than that of in middle latitudes, and this range is 18 kilometers in the tropics, while it is 14 kilometers in the middle latitude and 8 kilometers in the polar region. The upper limit of the troposphere is lower in the polar region and it is higher in the tropical region. This is why the occurrence of cloud are higher, I mean altitude wise it is higher than that of polar region. So, in polar region it could be up to 25,000 feet. By convention, the vertical extent of the atmosphere in which clouds are usually present, it is divided into 3 different layers: high, medium and low. Each layer is defined by a range of altitudes between which clouds of certain types occur most frequently. The layers overlap and the approximate limits vary with the latitude as shown in the following table. Some clouds usually have their bases in the low level, but may reach into the medium or higher level. I mean, sometimes what happens, the clouds which occur in the lower region, I mean which has already been categorized the low height cloud, may transit or may pass into the higher or medium level cloud. Here in this table it is given nicely. We can see here in polar regions the clouds height varies between 3 to 8 kilometers or from 10,000 to 25,000 feet, while in temperate regions it varies from 5 to 14 kilometers or 16,500 to 45,000 feet, whilst in tropical region it varies from 6 to 18 kilometers or from 20,000 to 60,000 feet, and it happens in the cloud category of higher heights or higher level clouds, while in case of medium height clouds in polar regions it varies between 2 to 4 kilometers, that is 6,500 to 13,000 feet. In temperate region it varies from 2 to 7 kilometers or 6,500 to 23,000 feet, whilst in tropical region it varies from 2 to 8 kilometers or 6,500 to 20,000 feet, while the low height clouds in the polar region varies from surface, I mean from the earth's surface to up to 2 kilometers or up to we can say 6,500 feet. In the temperate region it varies from earth's surface to 6,500, I mean it is more or less same in polar region as well as temperate region, and also it is same in the tropical regions, that is again from earth's surface to up to 2 kilometers or up to 6,500 feet. Now, I think the classification etc. we will discuss in next class. So, today we discussed about the formation of cloud, how clouds are formed, what are the processes by which a cloud can be formed, what are those circumstances which leads to the formation of clouds, what are the basic needs for especially the cloud condensation nuclei in the formation of clouds, and according to height how the clouds are classified.
With this note, thank you sir, thank you so very much for giving us in-depth knowledge on cloud formation and precipitation, and I think that we would be discussing about cloud formation and precipitation later on in our next lecture.
Yeah, I think tomorrow we will discuss the later part of different type of clouds, because this is here we just divided the clouds according to its height of occurrence, but there are so many types. I mean as far as the clouds types are concerned, there are huge number. So, and we will show some pictures of the clouds as well as of different type of clouds too.
Definitely, we would be discussing more on the clouds, the different types of clouds, as Dr. Arun Kumar himself said that he would be showing the various pictures of the clouds. Dear friends, I know that you always have queries and you always wanted to give your feedback. For this, we are giving you an email ID on which you can give your feedback or your queries which you would like to be answered. So, the email ID is info.cec@nic.in, and if you want to see this lecture, so for you we daily upload the lectures on YouTube, and this lecture too would be uploaded on YouTube very soon. By tomorrow you would be seeing it, and you can access it with number of times, the couple of times you wanted to see, and accordingly after watching, if you feel so that there is some questions which are required to be answered, then you can mail us. Definitely we would be coming again tomorrow and would be discussing more on cloud formations and the precipitation. Today we take your leave with a promise that we would be coming again tomorrow and would be discussing more and more. And with this note, I would want to thank Dr. Arun Kumar Srivastava once again for giving his precious time. Thank you sir, thank you so very much.